Hi, welcome to this session and thanks for joining us today as we relaunch CRESS as Spark. I'm Michelle Dion, as I mentioned, and I'm going to talk a little bit about some basics of data management. So for y'all who are in this session, what do you think of when you think of research data? Like what would count as research data? You can unmute yourself or you can type in the chat. Either one would be fine. Like what is your data when I say like you need to take care of your data? What would that be?
I think the data to answer our research question.
So would these be like Word documents, spreadsheets, PDFs? What type of items?
Depends on what kind of research you're pursuing. If it's qualitative, then it would be probably journal articles, books, and all of that. If you're pursuing quantitative, then it's going to be in Excel format. So,
Yeah. Yeah, so you can have lots of kind of raw data, scans of materials, downloaded files. You might have original data sets and then copies of it, of those data files that you've cleaned or analyzed. You might have the scripts that you use to analyze the data, and you might have drafts of papers or reports or memos that you've put together. So basically, when I'm in this talk talking about research data, I'm essentially talking about all your important documents, items, files related to your research work. So I'm thinking kind of very inclusively about what counts as research data. So Jay will know this image because I borrowed it from the Portage Research Data Management 101 module. It's really usually recommended that you think about the entire life cycle of your data and of your files. And so this image really, to my mind, illustrates nicely that, you start out by kind of making a plan for your research and kind of what types of documents and evidence you're going to collect. You then collect the data or create the evidence or the data, you clean it, you process it. And so it kind of really you're encouraged to think, when you think about research data management, about the entire life cycle, right? All of the different stages of your research, from when it's just a twinkle in your eye to when you've kind of published your papers and are thinking about archiving and potentially sharing your data with other users. And indeed, some of these stages will explicitly kind of prompt you or require you to think about research data management. So for instance, if your research involves the interactions with human participants, then when you apply for ethics approval, there will be several questions or parts of the ethics approval process that prompt you to think about your research data management and require you to report your plans for your human participant data in the ethics application itself. And then one of the things that I like to kind of remind everyone is that you also, part of your research data lifecycle is not just kind of what you have on your hard drive or your computer that you're analyzing, but it's also those documents or files as you collect them and while that information is in transit. And so you have to also think about those issues as well. As I mentioned, processing might be cleaning data, coding it. Analyzing it would be a similar next stage. Dissemination, usually for academic users, that would be when you're thinking about your published papers or a book or whatever your deliverable is that you're trying to produce and share with other researchers in the community. So you also need to think about, archiving your data at the end of your study. So sometimes you might need to destroy the data, but increasingly, including for funded research from SSHRC, for instance, there's an expectation that you would, to the extent possible and ethically allowable, archive and share data with other researchers, in part because this creates opportunities for other researchers to reuse your data, potentially to answer slightly different research questions. So really, we want to kind of think about the entire life cycle of your research data and ways that you can make sure that it's secure and backed up as needed. So there are some key questions that you would want to consider as you're planning your data collection or your research projects and making decisions. So I've pulled out a couple here that I think are particularly important for researchers. One is to think about the nature of your data. Are they public? Are they confidential? Are they highly sensitive? And in fact, McMaster does have policies that establish different criteria or standards for protecting different types of research data. And so they've put together a helpful classification matrix. I've included the link here, and I have a link at the end where you can get these slides for yourself as well. But they have put together a nice classification matrix that will kind of help you decide whether or not your data are confidential or what they call restricted, and whether you need to take additional measures to ensure that those data are safe and secure and protected in transit and while they're in storage. So if you're a McMaster affiliate, you'll certainly want to make sure that you're familiar with that classification matrix and think about the risk to your reputation in McMaster and potentially your human participants, if you do have human participants, as you think about your data management planning. You'll also have to think about how large are your files going to be, and it's not just the data files that you're going to collect, but all the other files associated with a research project, because ideally you would have these all in the same type of storage if it's at all possible. So you'll also want to think about, as you're planning to manage your data for a research project, kind of how many PDFs am I going to collect? How many scans? How many data files? Will I keep backup copies and multiple copies of data files for different deliverables or different publications? And how large will this collection of research data grow over time so that you can choose and make sure that you're picking the best place to store them? You also, if you're working on a team, want to think about who owns the data and then who needs access. And generally, you would want to minimize access to only those people that really need access. And this is partly potentially for ethics reasons, but also to avoid mishaps where maybe a team member accidentally deletes important data. And then you'll also want to think about the software tools that you'll need or that you'll be using to interact with the data for cleaning and analysis, and whether or not those tools require certain types of file formats, or are they available across the cloud, or do they run on local hard drives? Questions like that. So a key resource for this that I'd like to point your attention to is the Portage Data Management Plan Assistant. And there's the link there. And essentially, this is a really helpful interactive tool that asks you several questions similar to the ones I have above, but including ones that go into much more detail, that prompt you to think through your data management process and needs, and then pulls all that information together in an interactive, through the interactive tool to give you a plan, a document where you've got all of these answers together in one place. That is particularly useful for you as you're starting a new research project, but essential, I would say, for larger teams where you need everyone to kind of understand these are the types of data we're going to have, these are where we're going to store them, these are the restrictions that we have on sharing, those types of questions. So it's a really helpful tool that I would encourage you all to utilize. So I'm going to talk very quickly about some backup best practices, because this is often what people think about when they think about research data management. There's a saying that's 3, 2, 1. You should always have 3 copies of any important data or files. They should be stored on 2 different media, and at least one of those copies should be off-site or somewhere different from where you are. So if you have all 3 hard drives that have the data stored in your home or your office, that's not sufficient. So I have a couple of pictures here of what that might look like. So here's one version. So maybe you have a desktop and then it backs up to a time machine on a networked storage device. Maybe it also backs up that folder to the cloud on Mac Drive. And then maybe you have a laptop that also syncs to Mac Drive. So in this case, you would have 4 copies on 2 different media, one in the cloud, one on these hard disks, and then you would have at least 1 copy offsite. You might have another configuration that looks something similar to this, where you have a laptop that just pushes data to a bunch of different places. The important thing here, or gap, would be that you'd have to remember to take your hard drive from home to the office periodically to make sure that you're actually saving one of those copies someplace else. And here's probably the most common setup, particularly for students these days, would be to have a laptop and then something that syncs to the cloud, and then have a portable hard drive that has a second copy. And so this is less robust, but this meets kind of the minimum, I think, expectations for 3 copies on 2 different media and 1 copy offsite. So in terms of resources that are available to McMaster researchers here at Mac for backing up or saving additional copies of your data, faculty and staff have access to something called Mac Drive. And if you have a research team and members of your team are students or community partners, you can request accounts for them to be able to also use Mac Drive, even though they're not included by default. So Mac Drive is the recommended cloud storage tool by ethics, because it is on Canadian servers and it is backed up off-site. One thing I will point out, or two things I will point out about all of these cloud sources, is first that the owner, and usually that would be the leader or the PI of a research project, should be the one that creates the file system to make sure that they own and have the permissions and set the permissions for all of their users for any data that are collected. So this is not something you want to delegate to a research assistant. The PI should always be the owner and creator of the file system. And then you should also make sure that everyone on your team knows that they can use the desktop client that will automatically sync files from the web to their desktop if that is allowed by ethics and if that's something that you want your team to do. That ensures that people are always working with the most up-to-date copy of the data. I want to also point you to two other options that might be appropriate for special cases. So SEAL is the Secure Empirical Analysis Laboratory. SEAL is a part of SPARC, and has the ability to store sensitive, restricted data and still allow research teams to share that data with partners around the world. And so if you're interested in their services, I've provided a link there. And high performance computing, RHPCS, they also have backup data services for researchers that you have to pay for, but they do tape backups offsite for larger research projects that I want to let you know is also available. Some additional things that people might not think about always, and if you're not in this space and thinking about it often, but encryption, particularly for sensitive and restricted data, is very important. And so you'll want to have your hard drives encrypted. You'll want to make sure that the remote servers where you're saving your data are also encrypted. And you also want to make sure that data, particularly restricted or sensitive data, is encrypted in transit as it moves across the internet to the cloud and back to your hard drive. And email is not a secure way to share data. And so if you do have sensitive data with human participant information, you should never be emailing that. You should use one of these other tools for transferring data because most of them have some encryption in transit. This also, if you do encrypt your hard drives, that will require you to set up a password for your operating system so that if a phone or a laptop is lost, people can't get into the laptop or into the operating system to access the data. If you have restricted data, which is the highest security data, you'll also potentially want to set passwords on particular files that hold those data. You'll also want to consider the cost. One of the things that I've become aware of as my research Dropbox account grows is that my research assistants don't always have access to paid Dropbox accounts. And so their Dropbox may fill up faster than mine. And so you also should think a little bit about the team members that you're working with and what types of hardware setups they have and what types of file sharing restrictions they might face. So last year at SPARC, we had Scott Long come and do an event with us about research data management and the use of Stata. And he had a version of a saying that I thought was great, which is if you don't have a place to store your data, it won't be there when you look for it. It's kind of like your keys or your wallet. It won't be there if you don't always have a place to put it. And I think that you want to make sure that you adopt some best practices. I'm not going to be dogmatic and tell you how to organize your files. I'm just going to say, plan ahead, be attentional, and be consistent. And if you're working in a team, agree upon an organization system for your project folders. Think about original data, working copies of data, folders by deliverables, different papers and the such, and really get everyone on board to use the same filing system. Agree on a naming convention for all folders and files, and realize that you can put numbers at the beginning of names in order for them to sort in particular ways. It's also very useful to include the date that a file was edited or changed in the file name itself instead of relying on the modified dates, especially because some of these cloud sync services might tinker with some of those modified dates depending. And then always include an author or an editor initials in the file name. So when my partner writes his share of the paper and passes the paper to me, I open it, edit it, save a new copy with a new date, and put my initials so that everyone knows that I'm the last one to have touched that file. So here's just a screenshot of what a kind of orderly file system might look like for a particular project. And I'll be honest here, these are all empty dummy folders because my real files are not nearly as organized as I'm preaching they should be. But this is the type of organization that you would like to strive for to make sure that you're able to find all your data files. So how can Spark help if you're new to kind of managing large projects and large amounts of data? You can sign up for a research consultation and meet with one of us to think through your research data management plan, to talk to you about some of these resources, to help digest the classification matrix and talk about what kinds of data you have and what types of ethics issues might be involved, to help you decipher the ethics requirements of the MREB. And we can also talk to you about different tools for backing up and sharing your data with research partners.